All right, so we had a tiny bit left to finish here. So we had started out with this example 3 that gave us the average price of regular unleaded gas in December 2018. And then it gave us a standard deviation. This is using Chebyshev's inequality because we're looking for a minimum percentage. So those are the types of questions where we would be using Chebyshev's inequality. So we have to find the number of standard deviations because that's what the K is standing for. So mu is the mean. So mean minus some number of standard deviations, mean plus the same number of standard deviations. So at least this percent of the data lie within those standard deviations. So in this case, it was 2.5. So we plugged in 2.5 for K and then simplified this to make it a percent. That's why we multiply by 100. So this gave me 0.84 times 100 gives me 84%. So that means that a minimum of 80% of gas stations had prices that were within 2.5 standard deviations of the mean. Now it asks a follow-up question. What are the prices that are within 2.5 standard deviations of the mean? So the prices that are within 2.5 standard deviations, you have to actually use. Now, I hate the word average, but they use it sometimes. That's supposed to be the mean. The standard deviation is 0.06. So if the mean is 3.06, 2.5 standard deviations of the mean means 2.5 standard deviations below. So this represents 2.5 standard deviations. The minus means that that represents below. The 2.5 standard deviations within, that means that I also not only need to include the below the mean, but also the above the mean. So prices that are within 2.5 standard deviations means 2.5 standard deviations below and above. So the below, here's what I do to calculate it. That gives me $2.91. I'm rounding to the nearest hundredth because we're talking about money. 2.5 standard deviations above the mean, so 2.5 times 0.06, adding that to 3.06. In dollars and cents is $3.21. So this would be the second answer to my question there. Part B, what is the minimum percentage of gas stations that had prices between $2.94 and $3.18? So here is a question where I need to figure out how many standard deviations this is. So we kind of did that up here. So when I look at these values, 294 in relationship to 3.06, so 3.06, so I know $6 a gallon, so one standard deviation below would be just 3, right? If I go another standard deviation below, that's 0.06 again, that gives me 2.94. So this is 2 standard deviations. So now I make sure that the 3.18 is the same on the other side. 3.06 plus 0.06 plus 0.06 again, and you don't have to show this. I'm just illustrating to help you. I'm showing that both times I added and or subtracted the standard deviation twice. So that means that these prices are 2 standard deviations from the mean. So to find the minimum percent of gas stations, the minimum percent, not how many should be between those, the minimum is what Chebyshev says. I need to use now this formula again because now I know what K is. So K equals the number of standard deviations. So 1 minus 1 over 2 squared times 100 is going to give me the percent. Bless me, sorry. So 2 squared is 4. So 1 minus 1/4 is 3/4 or 0.75 times 100 gives me 75%. So we would expect if the data were bell-shaped, we would use the empirical rule and we would say that we would expect 95% of the data to fall within 2 standard deviations. But this isn't saying that. First of all, it didn't tell us that the data was bell-shaped. Secondly, it didn't say what percent, it said what minimum percent, which is what the clue is, the key word that tells us to use Chebyshev's instead. All right, next, I want to just give you a little hint. You can, in the same place yesterday, so maybe write it up here. If you want to check work in StatCrunch and you want to calculate standard deviation, variance, any of those in our StatCrunch options, what you would need to do is go to the exact same place. It's in the same menu as mean, median, etc. The one thing that I do want to point out to you is that if you want a population standard deviation, so meaning you want sigma, it's called the unadjusted standard deviation. So I believe that when we look at them, so you go to stat, summary stats, columns, you choose your column. There's one that says standard deviation, and then there's one that says unadjusted standard deviation. So you only choose standard deviation if it's a sample. If it's for a population, then you need to choose unadjusted. So I'm not going to write out the steps for you because, again, they're the exact same menu as in section 3.1. So that same place, stat, summary stats, once you've got your data in, this is the only thing that's new for that. I do want to go back. So if you understood what we did here, then you can probably quit watching for this last part. I am going to go back in and finish this last one. So if you had trouble with what we did here, then follow along with this and maybe a second time will help. We're not using the same formula because it says population rather than sample, but it's the same idea. Now, again, you are more than welcome to use the other formula if you want. I think that these ones are easier. I think they're less work. So those are the ones that I am choosing. Again, in the textbook, if you go within the actual examples, it can show you how to use the other ones if you would like. So the thing you have to understand, xi just means a data point. So when I see the sum of all xi squared, that means I have to take each data point, square it, and then this symbol, this summation, means add them all up. So the first thing I'm going to do is list the xi squareds, and then I'm going to do the sum. So if my first value is 3, that means the first squared value is 9. Then here that gives me 36. This gives me 100, 144, 196. So I've got all my squareds. So that tells me that the sum of all xi squared is what I get when I add all of those together. So adding all of those together, I've got 9 plus 36 plus 100 plus 144 plus 196. So that gives me 485. So in the formula, I now have this piece. I also need the sum of all xi. Notice that's in parentheses. That means do the sum first and then square it. So the sum of all xi just means the sum of all the original data pieces. So in this case, 3 plus 6 plus 10 plus 12 plus 14. So the sum of all xi in this case is 45. Remember, this formula is for the standard deviation. My directions say to find the variance and the standard deviation. Variance, look at this relationship, is sigma squared. If I square a square root, it undoes the square root. So it just gives me this whole fraction, but without the square root. So population variance, so sigma squared, equals, now I've got all the pieces that I need. Sum of all xi squared, that's right here. It's 485 minus, on my fraction within a fraction here, the numerator, sum of all xi, so that's my 45, to the second power. So 45 to the second power over, the denominator is n, the size of my population here. I have 1, 2, 3, 4, 5 items, so that's my n. That goes in this denominator as well. So now I'm going to simplify this fraction. So please make sure that you follow order of operations. So I need to do the 45 squared first. That gives me 2,025. Then divide that answer by 5. So that gives me 405. So I've got 485 minus 405 divided by 5. 485 minus 405 is 80. 80 divided by 5 gives me 16. So the population variance is 16. I know that the square root of the variance is the standard deviation. So that gives me 4. All right. If you were confused the first time I did it, hopefully that helps you out a little bit. And like I said, if you want to see the other two formulas by hand, look in the text. It does do those for you, but you have to make like a table. So it takes a lot longer to do that. All right, so that should hopefully set you up well for 3-2, which we will answer questions on next time I see you.